You know, melatonin is a hormone, and believe it or not, it's made in the brain. It's made in the pineal gland of the brain, and it's got a very powerful antioxidant status compared with vitamins. For example, melatonin is 5 times as powerful as vitamin C and twice as powerful as vitamin E. And it secretes only at night, and it's at night that we need it because that's when we go to sleep and when our brain repairs the cells of our body. And that's when melatonin comes out to do its work.
Each day, our body loses about 500 million cells. And at night, that's when our body replaces those cells. Through a process called cell mitosis, the dividing of cells.
And what it's doing is it's mopping up what are called free radicals. These free radicals are really the spare electrons left over from the process of making the energy which we need to repair ourselves in the first place.
Each night, as our body repairs itself, millions of free radical cells are created as a byproduct of cell mitosis. These free radical cells attack healthy cells. It is universally agreed that the free radical cell is the main causal factor in most cancer. Our body's main defense against these free radicals is its most powerful antioxidant, melatonin.
It passes into the bloodstream, and its job is to act as a natural antioxidant, a natural anti-cancer agent. Melatonin is a very, very powerful anti-cancer agent.
What it does is it acts as what's called an oncostatic agent, that is, it protects you against cancer. It controls the sleep-wake cycle so that you get a good night's sleep when you've got proper melatonin. It's an anti-aging molecule. In other words, by mopping up those free radicals, it leaves your skin and complexion looking younger. We have in our lab 12,000 studies which we've collected over the years, and that is more studies than have ever been published on paracetamol, which is the most common headache reliever. There's more scientific interest in melatonin than there is in paracetamol.
What are the consequences of having a reduced amount of melatonin?
Yeah. Well, you have a reduced amount of melatonin, and what happens then is that your immune system starts to be less competent for a start. You tend to get sleep disturbance, you can't get off to sleep, or if you do, you wake up and can't get back to sleep. You can have heart complications because melatonin protects your heart as well. And you're much more prone to disease because your immune system is not functioning at its best. So these are some of the things that happen when you have a lowered melatonin level. And for example, the average woman with breast cancer has only got 1/10 of the melatonin of a normal woman of her age. And for people with prostate cancer, they've got less than half the melatonin that they should have. Autistic children have less than half the melatonin levels that they should enjoy.
Reduced melatonin in night shift workers, because they're working at night and exposed to light, they don't produce nocturnal melatonin, is known to produce a 50% increase in breast cancer risk. And the International Agency for Research on Cancer, IARC, has actually classed night shift work as a class 2A probable carcinogen because of this melatonin reduction.
There are lots of studies now showing that people on night shifts or people who are blind have different cancer rates than the average population. And most of those studies support the view that the absence or the lowered melatonin has an adverse effect on health.
Because the body only repairs itself at night, melatonin is only produced when the pineal gland senses that no light is present.
What happens is that the pineal gland is light sensitive. It's sitting right where your brain receives signals from your eyes, that crossover point in the middle. It's called the suprachiasmatic nuclei, and the connections from there goes directly to the pineal gland to tell it whether there's any light around or not. If there's light around, then there's also interference with the signals the brain wants to send to our cells in order to repair them. So it says there's no point in the brain sending these signals out to our cells to tell them to repair, because there's so much interference that they won't hear it. So it waits, the brain waits until it's dark.
Melatonin production from electric fields, magnetic fields, radio waves.
Right, well, the Battelle Institute in America has done a lot of work on this way back from the late 1970s, in fact. And their scientists there, Barry Wilson and Dick Stevens and people like that, started thinking that because we know that if you turn the light on, then the brain stops making melatonin, they thought, well, maybe our brains can't distinguish between electric fields and that we make ourselves artificially, and the natural light that we all know happens during the daytime, because we just don't make melatonin in the daytime, for very good biological reasons. So they thought, well, maybe these electric fields are suppressing the synthesis of melatonin, and that in turn is leading to cancer, breast cancer particularly, in women, because they don't have the immunological protection that they would otherwise have.
So the brain interprets radio waves as being light waves?
Yeah, we don't know the difference.